All right, so we're all hurtling towards this 6G future, right? And our networks, they're getting crazy complex. I mean, everything is connected. So the big question is, how in the world do we protect all of that? Well, today we're going to break down a really smart new architecture for next-gen network security. It's called DPZTN.
So here's what we've got on tap. First, we'll tackle the big security problem that 6G brings. Then, we'll get into this idea called Zero Trust. After that, we'll dive right into DPZTN. What it is, how it works, how it did in testing, and, what this all means for the future of our networks. All right, first up, the 6G security problem. Because really, to get why the solution is so cool, you have to understand just how big the problem is. Our old security playbooks, they're just not going to cut it anymore.
So you've probably heard that 6G is coming, and it's easy to think, oh, it's just faster internet. But it's so much more than that. It's a total transformation. We're talking about a world where basically everything is connected. Your car, the city's traffic lights, sensors in factories, you name it. And trying to protect that massive, constantly changing environment, it means we have to completely rethink how we even do security. For the longest time, we've thought about network security like a medieval castle. You build a huge wall and a deep moat around it to keep the bad guys out. Simple enough, right? But what happens if someone gets past the wall? Well, then they can pretty much run wild inside. That's the problem. 6G needs something completely different. It needs what's called endogenous security. Fancy term, but it just means security isn't a wall around the network. It's woven into the very fabric of the network. It's built in, always watching, and ready to act from the inside out.
Okay, so that brings us to a new rulebook. To tackle this massive challenge, this new way of thinking came along called Zero Trust. The name kind of says it all. It's a huge shift from trust but verify to never trust, always verify. It's a powerful concept for sure, but the first versions, well, they had some growing pains.
So what is a Zero Trust network? The core idea is actually super simple, but it's a game changer. It completely throws out the old idea of a safe or trusted internal network. Instead, the motto is simple: trust no one, seriously, and verify everything, all the time. It doesn't matter if you're already inside the network or not. Every single time you try to do something, you have to prove who you are and that you're allowed to do it.
Okay, now look at this. This chart is really where you see the gap. Other Zero Trust systems, they might have one or two of these features. Maybe they're distributed, or maybe they're a little adaptive, but they're usually missing key pieces. What makes DPZTN so special, and what we're talking about today, is that it's the first to really bring all of these things together. It's distributed, it's dynamic, it has security built in, and it covers authentication and access. It's the whole shebang, and that's what makes it so powerful.
And that brings us to the star of the show, DPZTN. This is the next evolution of Zero Trust. Now, that DP in the name stands for data plane, and that is absolutely crucial. It means security isn't happening in some far-off control room. No, it's happening right on the digital highway itself, where the data is actually flowing. And that's how security gets smart and fast.
So what gives DPZTN its edge? Well, you can think of it as having three core superpowers that all work together. Let's break down what they are. Okay, superpower number one, the ZTNE, or the Zero Trust Network Element. This is the enforcer, the boots on the ground. Think of it like a super fast, super smart traffic cop. But this cop isn't just standing at a checkpoint. They're on every single lane of the data highway. Because it's built right into the network switches, it can inspect traffic as it's flying by in real time. It's not just checking your license at the border, it's watching how you drive the whole time.
Superpower number two is blockchain. Now, why blockchain? Because you need a rulebook that nobody can mess with. Think of it as the system's public notary, a totally unforgeable, tamper-proof ledger. All the identities, all the access rules, they're all logged there. And because it's decentralized, no single person or thing can go in and secretly change the rules of the game. It keeps everyone honest.
And finally, superpower number three, the BBE. This is really the brains of the whole operation. It's a special algorithm that acts like a real-time behavior judge. The best way to think about it is like a credit score, but for your network activity. Every single thing you do is analyzed, and your trust score goes up or down based on your actions. This is huge. It means trust isn't a one-and-done thing at login. It's something you have to continuously earn. This is what makes the whole system so incredibly dynamic.
So, how does DPZTN actually assess trust? We've got the pieces, right?
the enforcer on the highway, the tamper-proof rulebook, and the real-time judge. Let's see how they all work together, from the moment you log in to every click you make after that. It all works in a constant loop. So, step 1, you register. Your identity gets verified and locked into the blockchain. Can't be faked. Step 2, you get your initial access. And this is key. It's based on the least privilege idea. You only get the keys to the doors you absolutely need to open, nothing more. Then, from that second on, the ZTNE, our traffic cop, is watching everything you do, every packet of data. And finally, the BBEA, the judge, is constantly crunching that data, updating your trust score, and potentially changing your access rights on the fly. And that's the absolute game changer right there. Trust is no longer this static thing you get when you log in. Nope, it's something you're constantly earning, second by second. If you act normal, you're fine. But the moment your behavior looks shady or just plain malicious, the system doesn't wait for a human to step in. It automatically and instantly starts shutting doors on you.
Okay, so this all sounds amazing on paper, right? But the real question is, how does it hold up when the rubber meets the road? Let's take a look at how DPZTN actually performed when they put it to the test.
First question, can it scale? I mean, can it handle a ton of traffic? The answer is a big yes. They threw 10,000 concurrent users at it, and the system didn't even break a sweat. Performance stayed stable. That's huge, because it shows this isn't just some lab experiment. It's built to handle the kind of traffic we expect in the real world.
And here's the part that really blew my mind, the speed. You'd think with all this going on, the constant monitoring, the blockchain checks, the trust score calculations, that things would slow to a crawl. But no. The average time for a user to get authenticated and get access? About 1 second. Just 1 second. For that level of deep, continuous security, that is unbelievably fast.
This chart right here tells the whole story. Look at that. When a user is just doing their normal thing, their trust score is nice and high, up around 0.8. They're trusted. But look what happens the instant they try something malicious, like launching an attack. Bam! The score plummets all the way down to less than 0.2. And that massive drop is the trigger. The system sees that and immediately slams the door, neutralizing the threat before it can do any real damage.
All right, so where does this leave us? What's the big picture here? Let's talk about the future of network security and why this shift really matters.
So, when you boil it all down, DPZTN is really a blueprint for the future. It's a future where security is baked in from the start, not just bolted on as an afterthought. It's a world where trust isn't just given, it's earned, continuously. It proves that we can have incredibly powerful security that doesn't slow everything down. And, maybe most importantly, it shifts us from being reactive, cleaning up a mess, to being proactive, stopping the threat before it even has a chance.
And that leaves us with one last, kind of mind-bending thought. We started this whole thing talking about security as a fortress, a castle wall, but where we've ended up is a network that's more like a real-time judge of character. So if our networks can evaluate our trustworthiness in every single moment, based on every single action, what comes next? How does that change not just how we stay safe online, but how we interact with the digital world and each other?